By the way, on that last problem, if you wanted to figure out what percentage of your petri dish was covered, these things are so circular. Like if this was the beginning of the colony, right? I would need to know the area of that circle. And remember actually, maybe you don't know this yet. Maybe that's something we'll do next year in math too. But the area of this circle is pi times the radius squared. So I could calculate its radius and then calculate the area of that. And if I zoom out and I calculate the radius of if I know the radius of the entire petri dish, I can figure out its area, and then the percent coverage would be the this number, this thing's area, divided by the total area. But that's not what this problem's about. We're supposed to find the first four terms of each of the following sequences. So if you take a look at these, this first one is actually an explicit formula, right? And the second one is a recursive formula. So let's do the first one, the explicit one first. It says find the first four terms. So if I'm doing this for A, right, all I'm going to do is I'm going to plug in a 1, a 2, a 3, and a 4 for n. So I'm going to be looking at when n is 1, when n is 2, when n is 3, and when n equals 4. So if I plug, and it's going in right here, right, n to the 0 power, or n minus 1 power. Actually, that's a little small, so let me put the equation down here. So I'm going to be plugging in values for n and calculating it. So when I put in n as 1, this becomes 3 times 5 to the 0 power, which is just the number 3. That's 3 times 1. If I plug in n as 2, the 2 minus 1 becomes 1, so that's 3 times 5 to the first, which is 15. You can see each time I move forward here, I'm multiplying by the number 5. So if I take 15 and multiply by 5, I believe I'm at 75. Let me do 15 times 5 on my calculator, and I get, yeah, 75. So we're going to place 75 here. And then one more time, I'm going to do 5 to the 4 minus 1, so 5 to the third. So I'm going to do, or I could just take the last value, right? 75 times 5. I could do that. 75 times 5 is 375. But also I could calculate that by just plugging in for n, right? I could go 3 times 5 raised to the power of, and I would use parentheses here, raised to the power of, open parentheses, um, 4 minus 1. Not that I couldn't do that, but you can see I do get the 375. Okay, so that's the one with the explicit formula, right? You just plug in n and it'll tell you that the value at that spot. What about this recursive definition? So remember, in a recursive definition, you have to be told where the sequence starts, and you also have to be told separately how to move forward in that sequence. And you can see this is telling me the first term in my sequence is 10, so I am starting at 10. And then it says to move forward, right, to figure out the next term, the term after the nth term that you're at, what you're going to do is take the value where you're at and multiply by -5. And you just keep multiplying by -5. So this is the recursive definition, right? So if I'm at 10, my next one has to be -50. And if I'm at -50 and I'm going to multiply by 5, I believe that's positive 250. So you can see what I did there is I took each time as I jump forward, I'm multiplying times -5. Right? As I jump forward here, I'm multiplying by -5. And when I do that, I got positive 250. And then for my last jump, when I take the 250 positive and multiply again by -5, I get negative, I think it's 1,000. Shucks. Let me grab my calculator. It's actually clear. Yeah, it's going to be negative 1,250. Negative 1,250. Okay, so that's a nice review of what recursive definitions look like. Um, Basically, it's just recording what you do to get to the next pattern in the term. So this is the recursive one right here. Remember, a recursive definition also has to tell you where you start. So we're starting it, and then what you do to move forward. In this case, we're multiplying it by -5.